Welcome to The Explainer. Today, we are jumping right into Chapter 1, How to Approach AI System Design Interviews. We're going to demystify one of the highest stakes and, frankly, most misunderstood hurdles in tech today, using an insider's playbook from Level Up Labs. If you've ever wondered how the people actually running these loops evaluate candidates, well, you are absolutely in the right place. There is a quote from the playbook that perfectly captures the reality of this interview. It says, "This is where an interviewer stops asking whether you know what RAG stands for and starts asking whether you can design a system that holds up in production." That right there is the real test. It's not a vocabulary quiz for engineers, product managers, or strategists. Simply knowing what a vector database is won't tell an interviewer when you'd actually reach for one, or more importantly, what you'd build around it to make sure it fails safely. So here is our roadmap for Chapter 1. We'll cover what the round actually tests, why AI design is essentially ML design, how to scope using a problem-first approach, and finally, we'll break down the 5-layer design spine. Let's kick things off with Section 1, what the round tests. Ultimately, they are grading your judgment. You have to realize that interviewers are not just sitting across the table giving a letter grade to your whiteboard diagram. What they're actually doing is grading your judgment under ambiguity across 4 core competencies. First up, can you scope before you architect? Strong candidates will spend those critical first few minutes narrowing down the problem, while weak ones, they just start drawing boxes. Second, are you reasoning about trade-offs out loud? They want to hear you weighing things like retrieval versus fine-tuning or autonomy versus control. Third, you need to know exactly how the system breaks. What is the blast radius when a model inevitably produces a wrong answer? And fourth, you have to connect the design to real production. How are you evaluating it? What are you actually monitoring? Moving right along to Section 2, AI design is ML design. This is a crucial mindset shift you have to make. Make no mistake about it, AI system design is just machine learning system design. The core discipline hasn't fundamentally changed. You are still going to start from requirements and metrics, and you're still going to pick the absolute cheapest thing that clears the bar. But you do have to completely reset your expectations about one specific component. Think about traditional software for a second. Tests are basically a final gate before shipping, right? But in AI systems, models are non-deterministic. They do not return the same thing every single time. And worse, they can be confidently wrong. That means evaluation has to sit at the absolute center of your design. That is the big aha moment here. Evaluation is exactly how you decide if a change is safe, and it's how you catch a model that's getting quietly worse over time. If you just bolt evaluation onto the very end of your interview, you're going to sound like someone who has never shipped real AI. All right, Section 3, scoping with problem first. This is all about working backwards from the pain. Before you sketch a single line of architecture, there is some critical pre-work that separates the real pros from the candidates who just throw AI at a whiteboard. You need to use the Level Up Labs problem-first framework. Why? Because in AI systems, the most expensive failures are usually designed in before a single prompt is even written. This framework is your absolute rescue tool. It forces you to work backwards from the actual business problem and the user's pain, scoping incredibly hard until you find the smallest possible AI intervention. So what does that actually look like in practice? Well, there are 4 sequential questions you've got to establish out loud in that interview room. First, pinpoint the user and their pain. Give them a named role and a real task. Second, define a measurable outcome. Literally, what changes when this works? Third, narrow the AI intervention until it hurts. Please don't go for full autonomy right out of the gate. Propose a single workflow and let a human handle the results. And finally, define the system and safety. What are your guardrails and what is the rollback plan? Asking the right clarifying questions early on will completely reshape your entire design. For example, try asking, what is the cost of a wrong answer versus a missed one? If a hallucinated wrong answer could cost a company millions of dollars in liability, well, your entire architecture just pivoted. It now has to lean heavily towards safety, human-in-the-loop approvals, and incredibly strict guardrails. Which brings us to Section 4, the 5-layer design spine. It's time to actually construct the system. Okay, we've scoped our problem, now we start building the stack from the ground up, starting with Layer 1, the model. This is your foundation. It is the single non-deterministic component of your entire system. You pick a model that clears the bar for the task, but remember this, the model is just the engine. The real interview is about everything you construct around it. And that naturally brings us up to layer 2, the wrapping layer. Honestly, this is where most of your design lives, and it's exactly where you should spend the bulk of your time in the interview. It's all the architecture wrapped around the model. It consists of knowledge, like retrieval over your own data, tools, which are the typed actions the system can actually take, and memory, which is what the system needs to remember across a user session. Next up is layer 3, evals and guardrails. Remember how we talked about non-determinism earlier? Well, this layer is the direct consequence of that. Evals have to be treated as first-class components. This means setting up offline measurements to catch silent degradation and online guardrails, those crucial runtime checks on inputs and outputs that physically stop a bad AI generation from ever reaching your user. Moving higher, we hit layer 4, production and ops. This is the reality check. It's what it takes to actually run this thing at scale. We're talking surveying, latency, cost, observability, and rollback plans. You have to balance the classic cost, latency, and quality triangle. Knowing whether a system lives or dies by its latency budget versus its observability, that is exactly what real-world experience buys you. Finally, we top off the whole building with layer 5, optimization. I want you to notice exactly where multi-agent systems live here, at the very end. Things like model routing, caching, and multi-agent architectures are final optimizations. They are not starting points. Reaching for them too early is pretty much a guaranteed way to fail the interview by designing a completely unworkable system. At the end of the day, system design is ultimately the act of composing these 5 layers into one coherent stack to solve a specific problem. By shifting the weight between these layers, this single spine can produce wildly different architectures. You could build anything from a lightning-fast customer support bot that relies heavily on caching, all the way to a high-stakes financial decisioning tool that relies entirely on strict guardrails. And that wraps up our explainer. But before we go, I want to leave you with one final provocative question to think about. Can you design a system that actually holds up in production? Because it's really not about stringing buzzwords together. It's about composing a resilient, measurable, and safe architecture. I hope Chapter 1 of this playbook leaves you absolutely ready to apply these 5 layers to your next real-world build. Thanks so much for joining me today.